chicka, bow, chicka, wow, wow.
All right, let's take a look at the distance formula. The distance formula is used to determine the distance between 2 points in a Cartesian plane. All that means is that we've got the coordinates of 2 points and we're trying to find out how far is between them. So let's take a look at an example up here. So what is the distance between the points 4, 6 and negative 3, 9? Well, I'm going to plot those points on my Cartesian plane and negative 3, 9. And you don't need to plot them, but if you're a visual learner, it's good to do. It also helps kind of illustrate it. And I'm going to call this point A. I'll write in the coordinates here. And I'm going to call this point B. Just gives us a way of referring to them and keeping them separate from one another and writing the coordinates. Now, let's take a look at the distance formula. Now, before I show it to you, a lot of people think it looks kind of scary, a little bit nasty. And it looks it, but it's not once we get to work it. It's really just an application of Pythagorean theorem. So here's the formula. And it basically says that the distance between 2 points equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And that looks a little bit confusing, but again, as we break it down, you'll find out that it's not. So first people are wondering, well, where's x2, x1, y2, y1? Where do they come from? All it refers to is I've got 2 points. I'm going to call point A, I'm going to call that point 1. And so I'm going to say it has a x coordinate of 1, of x1, pardon me, and we'll call y1 the y coordinate. So the 1 just refers to our first point. So for point B, we'll call those coordinates x2 and y2. And that just gives us a way of distinguishing the x coordinates of our points and the y coordinates of each of our points. So after that, we're just going to fill in our values. So x2 is the x coordinate of our second point, that's negative 3, minus x1, the x coordinate of our first point, which is 4. I'm going to square that, plus y2, the y coordinate of our second point, in this case it's 9, minus y1, the y coordinate of our first point, which is 6. And we're going to square that. And now if you remember order of operations, we've got to do the brackets first. Let me try that square root sign again. A little bit better. So we're going to do our brackets first. Negative 3 take away 4 is negative 7. And then 9 minus 6 is 3. Now, a lot of times people wonder, well, where did this negative 7, where did the 3 come from? And I basically said this is an application of Pythagorean theorem. And so I'm going to draw a right angle triangle here. All right angles right up here. And what we notice is that the distance between A and B is the hypotenuse, or the longest side, of this right angle triangle. Now, when you do Pythagorean theorem, you need to know the 2 side lengths. Well, the 2 shorter side lengths. Well, this side length is 1, 2, 3, 4, 5, 6, 7 units. And if we go down here, x2 minus x1, well, that's the difference in my x coordinates, or how far I move left and right. 7 units. Here it's saying negative 7. Now, that is a little bit different. All the negative is referring to, though, is my direction. I started here, and I moved in a negative direction, or to the left. So it's 7 units to the left. So the negative just refers to the left. And then I went, if I look at my other side, or the difference in my y coordinates, 9 and 6, we went up 3. And so my other leg of this triangle ends up being 3. This is actually called vectors when we divide a diagonal movement into a horizontal component and a vertical component. So there we go. After that, we're going to square our values. Now, a lot of times people make a mistake here, and I want to show you something important. So let's take a look at our calculator here. When you put this negative 7 squared into your calculator, a lot of people are just going to go negative 7x squared like that, and you're going to get negative 49. Well, it doesn't make sense that a side has a length of negative 49. So it's important that you put in the brackets so that we end up with negative 7 squared. And what this means is that we're squaring both the 7 and the negative, and that's going to give us a value of positive 49, because a negative times a negative is a positive. When you're doing it up here, it's basically using order of operations and squaring the 7 first and then making it negative. And so you want to make sure that you do it like it is down here so that your value is positive. And it should always be positive. We're only referring to positive distances here because I'm not really concerned with the direction. So negative 7 squared gives me 49 plus 3 squared. I'm going to do that in my head. 3 times 3 is 9. And then after that, remember, before we take the square root, we're going to have to add them together. So 49 plus 9 is 58. So the distance equals the square root of 58. Some of you may want to leave it there, and you could do that. I'm going to, plus the square thing, I'm going to take the square root of 58, and we'll get a decimal approximation. So that's approximately 7.6 units. And since we don't know how much one of the blocks is, for now we're just going to have to leave it at units. You could also leave it at the square root of 58, and sometimes your teacher might prefer you to do that. And so there we go. Last thing I'm going to do, I just got a little ruler here, and it's not perfect, but we can take our ruler and just make sure that we're in the ballpark. Let me rotate it down. And let me see, we've got 1, 2, 3, 4, 5, 6, 7, and just over 7.5. So that seems to fit. And there you have it. Thanks for watching. Check out our other videos. Bye-bye.
You're still here? It's over. Go home. Go.